Alright, so in an earlier video I showed you how to set up these dashboards. So here's my tuning dashboard the way I have it. And right now the car's not running, but we're hooked up to the TehEdge device, and the TehEdge device is piggybacked onto the ECU and is recording and picking up several signals off the ECU. We have the wideband O2 sensor in the exhaust stream. That's the lambda reading here. And we're reading natively out of the ECU RPM, cylinder head temperatures, and airflow from the air meter, the mass airflow meter, in grams per minute. This next field is a calculated field which is derived from the combination of RPMs and airflow total. So we take the total airflow and divide it by RPMs, and we come up with airflow per rev. Right now this number's off because we're not actually running. We're really at 0 or 1 RPM. The injection pulse width is also off because the car is not running yet. So what we're going to do now, so you can see this record, how this guy works live, so I'm going to go ahead and start the car. This is a 1984 Porsche 911 3.2 liter with some modifications. So now the car is running, and what you're starting to see is how this thing works. So it's idling right now. It's idling at 0.95 lambda, which is almost perfect air-fuel ratio. It's slightly rich beyond 14.7. It's probably running at 14.2 or so. We can see the RPMs are running about 1,000 RPMs. Cylinder head temps are at 65. We can see all these signals over here as well. So the orange line is cylinder head temp as it warms up. The red line is the actual lambda reading. Okay. The white line's the RPMs. They're starting to drop and settle in as warm-up continues. And the airflow per rev is calculated at 0.5 grams per minute. And then based off this calculation and the size of the injectors, we calculate the injection pulse width at 1.6. So that's pretty much how it looks when it's actually running. If I step on the accelerator here for a minute, I can elevate the RPMs and the pulse width goes down. And that's because at a higher RPM and neutral, the pulse width is going to be lower and lower, okay? So basically we're at 2,000 RPMs and we're running a little rich. And now we'll come back down. And now we're at idle, all right? Now the reason it's running rich is because I was experimenting with minimum pulse widths, and I set the minimum pulse width to 1. And that's why I will never drop below 1. At any rate, this gives you a pretty good idea of how this guy actually works. Now, if I want next is I can bring up my TunerPro, which allows me to interface with the chip emulator that's built in on the chip. So first thing, actually, I got to plug in TunerPro. So we'll get TunerPro, and now I'll go ahead and tell it to communicate with the Ostrich device. And there it is. Hardware Ostrich is now communicating with it. And I can open something simple up like a fuel map. The fuel, that's a part throttle. Let's open up an idle map. And you can see that right now, well, TunerPro has a lot of cool features. So let's put this thing in emulation mode. And then let's quickly put it in hit trace. And it's going to tell me that I'm picking out of these maps right now. That's what the yellow field tells me. So what I could do real quick if I feel like it is I can grab these here and I can execute and fill this with, right now, let's fill it with 0.9, all right? And I can hit execute. I change that value to 0.9, and now I quickly say flash it. Now, as soon as I flash it, you see the result here on the lambda. This is live tuning. I'm actually tuning with the engine running live. I'm making changes in TunerPro to tables and immediately seeing those changes reflected down inside of on the chip. Okay, so what I'll do is I'll reopen up my file because I don't want to save the changes, and go ahead and hit open, and then now I'll just flash the original file back out, and instantly this guy will climb back up. I can do the same thing with ignition maps if I feel like it. I can grab an idle and ignition map. I can do hit trace, which is invaluable. This is the really most important part of any live tuning. If I step on the accelerator, you'll see that well, now I'm in the part throttle map. So hold on a minute, I'll show you that. So if I open up a part throttle map and I hit trace, I'm not in the part throttle map because I'm at idle. But as I step on the gas, I move into it. And as I step more and more, it slides up. Okay? So pretty much that's how this guy works. I could take an idle map like this, hit the hit trace, and I can take these first few rows, and if I set all of this to, let's take a value like, let's give it a nice advanced ignition. So if I've set the idle ignition to 20 across all these rows and flash it, the RPMs will climb up because the ignition value is a little bit better for the motor. All right. If I then decide to take the ignition out and set it to 0, top dead center, and flash that, you will see that now he's not going to want to idle, and the car might actually even stall. The optimum, I like to run this guy at around 7 degrees. So what I can do, so I don't have to remember all these changes, is I made a lot. Don't save the bin, reopen the bin, and flash the bin up again, and bingo. Pretty much that's how I tune, live tune, using TunerPro with the Ostrich2 from Moats as the emulator, and then using WinLog with the TehEdge device. The TehEdge products are really good products, and the bottom line is the WinLog dashboard is really key to being able to basically build your gauges any way you want. Now, as I said, sometimes I might not be live tuning, and if I'm not live tuning, I could do something like this. I can come over here and pick my other dash configuration, open a new dashboard. Well, that's a new dashboard. Let's open a dashboard and open up my other full metric dashboard. And there's another view where I can see RPMs on a rotary dial, and then I can see the graph still down below and different things. But I don't use this one too often. I actually use this dashboard here, Sal's full tune, and this is the one I use a lot because I can see all my signals graphed here, and in addition to seeing all the signals graphed, I can also still see what I need to see. Sorry, that's the recorder. I can still see what I need to see when I'm in TunerPro. So it allows me to lay TunerPro on the left side of the screen and then lay the WinLog on the right side of the screen and see everything on one screen. And when I'm dyno testing on a dyno, I love to watch injection pulse widths here, airflows, and basically be able to instantaneously on a low dyno change a value in any cell and know what cell I'm in TunerPro. That concludes the runtime demo of my setup.